So now we're going to come to one of the absolute most amazing and cool features of Python. And this is called the list. You may have seen something like this before if you've programmed in C. There's something called an array, which allows you to enter data, and usually similar data, of any length. You can have an array of size 1 or 2. You can have an array that's 1,000 units long. You can have an array 1,000,000 units long. An array allows you to store multiple values. Well, Python calls it a list. And a Python list can do anything an array can do, but it can also do a lot more, as we will see. Python lists, it provides all the usability of an array, but so much more. It's absolutely amazing what you can do with it. But let's just start with simple examples. Why would you ever have a list in a program? And if you've never programmed with arrays or lists before, it's like, why do we care? Well, let's say we wanted to store all the scores in an Olympic competition where the judges each give a rating from 0 to 10. And we want to collect these all together and then do operations on the entire group. Well, we put them in a list, and you're going to see a cool little program that operates on that list. And if you represented it with separate variables, which you could do, it would be a lot less inefficient. So we want lists to efficiently deal with groups of data. But it doesn't have to be numbers. For example, we can have a list of members of a rock band. So there's a certain rock band somewhere in the world where there's four, in this case, there's 4 strings in this list, and the members that are named by these 4 strings are John, Paul, George, and Ringo. So those could be in a list. But also, one of the ways in which Python lists are much more versatile is I don't even have to have a list of the same data. I can mix data if I want. Now, there are limitations to that. If I put mixed data in a list, there's certain things I won't be able to do. I won't be able to sort the list automatically. I won't be able to find minimum or maximum values. So probably you just want to stick to the same kinds of data or compatible data. But this shows you how flexible Python lists are. I can mix data if I really want. And one of the things I can do, which is amazing, is I can even have lists made up of other lists. Now, why would I ever do that? Well, this is how you create 2-dimensional lists, or even if you want 3-dimensional lists. That's how you do it. So we're not going to cover 2 or 3-dimensional lists very much in the course. I just want you to know that you can do this all you want. So you just saw a way I had of creating lists. I can do it directly in one statement. Another way of generating a list is I can start out with an empty list. It's just bracket, bracket, right? Close bracket, open bracket, close bracket. That's actually a legitimate list. It is an empty list, but it is still a list. Okay, it's like an empty set in a way. And then if we want to add members, we can do that at any time. We can do this dynamically, so we can grow the list or shrink the list anytime we want in response to program conditions. And the way to grow a list is to use the append method of lists. All lists have the append method. And the append method simply says, add this thing to the list. In this case, we've added Mo, started empty. We added Mo, we added Larry, we added Curly, and now we produced a list with 3 elements, Mo, Larry, and Curly. One reason I emphasized indexing and slicing on the string lesson is that lists essentially support almost exactly the same capability, but rather using it to index or slice characters, it indexes or slices entire members of the list or elements of the list. So just as we can index strings to get individual characters, we can index lists to get individual elements of that list. So we have John, Paul, George, and Ringo. Each of those is an element. And we can number them. If we want to use positive indexing, non-negative indexing, they run from 0 to -1, n-1 rather. They run from 0 to n-1, where n is the number of elements in this case. Or we can use negative indexes, and they run from -1 to -n, where again, n is the number of elements. If I use indexing, I'm going to get an entire element, not just a character. I'm going to get a whole element out of it. And we can slice lists all we want, and it's the same syntax. And now here I basically just repeated all the things we can do with strings, we can do with lists. And remember, the first argument in slicing is our beginning position, and then we will get a sublist, in effect, that includes all the elements up to but not including the second element. And if we do blank colon blank, then we're going to get a member by member copy, which will copy the entire list. And there is that optional third element that if it's -1, it will just reverse position through the list, or we can put in 2 and we'll get every other element. So here's some examples. So we'll go back to, we're going to do a demo on this, but real quickly, our list is going to be made up of John, Paul, George, and Ringo. And by putting in different numbers, we can get different sublists. First thing we have to do, before we can operate on a list, we actually have to create the list. Because if you try to slice a non-existent list, you are going to get a very unhappy Python. So Python wants us to create this list, which I will do directly. I could do it by appending each one of these, but instead I'm just going to type them all in. All right, so a list, and if I print that out, if I ask Python what that is, it prints the list. And notice it puts in the brackets saying that's a list. Now, slicing, it works just the way it does with slicing strings. So what happens if I say 1:3? Well, element 1 is actually the second element, remember, because we're zero-based indexing. Second element's Paul. Element 3 is actually the fourth element because it's zero-based indexing. So it will say, start with Paul, give me everything from Paul up to, but not including Ringo. I should get 2 guys. I do. Okay, so they did exactly what I thought. Another slicing example is we say blank colon 2. Well, that will start at the beginning of the list, and it will give me all the elements up to element number 2, which because we're zero-based indexing will be George, so that should give us the first 2. Oh, it did, John Paul. And let's see what else. Because we are so sophisticated about slicing now, we ought to know that -2 colon should just give us the last 2 members, right? If I remember correctly, and yeah, it does it. So you should notice if you go back and you replay the lesson on strings, it's using the same principles, but rather than getting a substring, it's getting a sublist, and it's accessing entire elements at once. It's otherwise the same syntax. Now, another cool thing about lists is assuming you use compatible data. Remember, you can't intermix numbers and strings and expect it to sort. But another cool thing about lists, lists support all kinds of methods. And one of the most useful is sort. So I have this list, John, Paul, George, and threw in this guy named Brian. I don't know who he is. I guess he was the manager. So if I then say a list.sort, it will produce a sorted version of this list. Now, an important distinction here is it doesn't sort the original list. It produces a new list, but this version of the list is sorted. But if I want, I can reassign the variable to be the sorted version. Another cool thing I can do with lists, just to show you how convenient this is, and this I believe is also on the exam, is I come up with a list, and then I can use the in keyword. That's another keyword. You can't use it for your own variable names because it has a special meaning. And it does exactly what you'd think. So I have a beat list that has these 4 names. They're 4 different strings is all they are. And I can say John in beat list. If John, and remember it's case sensitive, if John is one of these 4 strings, it will say true, which it does. And then I say, well, is Pete Best? A guy named Pete Best, is he in this list? And it will come back false because it looks at the list and says, no, I don't have that. It's not in there. So the in keyword, very useful in Python. Now we're going to discuss a series of functions. It's going to lead up to a really cool little app, and you'll be amazed at wow, this could really be used in real life. And these are a little strange because these are actually functions. They're not methods. And one quirk of Python is that some of the most useful functions are functions, meaning they don't use the dot syntax. And sometimes your most useful functions have dots, and they're methods. And there's really no way around that. You just have to remember that some things are functions and some things are methods. It's kind of annoying, but you just have to learn or look it up. But right now, I'm only going to discuss a few of them, and hopefully you can remember these. Here are the functions. So if I say min, give it the name of a list, that will return the lowest element. And this is going to be very useful in an upcoming application. If I say max, give the name of a list, it will return the highest ranked element. And with numbers, it's high or low. With strings, it will use code page order, which essentially is alphabetical order in most cases. The len function, you're going to use this all the time in a lot of applications. Len is simply the number of elements at the top level. So if you have a two-dimensional list, this is the number of elements at the top, usually the number of columns. But don't worry about that. Just think number of elements. LEN stands for length, number of elements. And then sum, this is really cool. I didn't even know about this for the first year I was programming with Python. If I take a list, give it as a single argument to the sum function, it of course gives you the sum. And in the case of 1, 2, 3, it adds them together, produces 6. Also, another method I want, now this is now a method. It's not a function, unfortunately, so a little inconsistency here, but this is extremely useful. Once we get into methods, we have to use the dot syntax, and sometimes you just have to look it up. Is it a function or a method? This one is a method. We use the dot syntax. So we give it the name of the list. We say dot remove. It will remove the named element. So if Pete is in the list, and we say dot remove Pete, it will remove Pete if he's there. However, if you try to remove something that's not there already, you will get an error. So check to see if something is in the list before you actually remove it. Before we get to this cool application, there's something called tuples. If you use bracket and then elements in bracket, that is a list. It supports everything we've been discussing. There's also something called a tuple, which is used a lot. The difference is you'll see open paren elements and then close paren, or just no parens at all. That creates a tuple. A tuple basically is the same as a list with a couple of differences. It, first of all, is immutable, so you cannot change data in a tuple, and that way it's like a string. And tuples, because they are immutable, do not support all the same operations that lists do. You cannot do anything on a tuple that would change the content, but you can with a list. We've seen like the remove. You can remove something from a list. It actually changes the list data itself. So lists and tuples are similar. Lists are actually much more versatile. So I've been leading up to a fun application, and it's fun just because it fits a certain context. So what happens in the Olympics? You get a bunch of these scores, and the standard procedure has always been you throw out the top score, you throw out the bottom score, you then average the rest, whatever remains, and that's just adding up all the values, and then you divide by the number of values that remain. That gives you the average, and then that gives you the actual score that's used to determine who gets the gold medal, and the other medals for that matter. So for example, here we have the scores, 8.2, 8.3, 2.3, that's probably the Russian judge, and then 9.9, that's probably the Canadian judge, and you throw those out, take whatever's left, and then you average it. And the sum function and the length function makes that just so easy. You don't have to write a loop. We'll get into loops, but you don't have to write a loop adding up all the elements, and you don't have to count the number of elements. You just say sum divided by length. So lists just do so much for you, so you don't have to do much programming. And this is going to be cool because you could actually use this at the Olympics, believe it or not. So they probably have it programmed in a cell phone or something. Okay, let's enter the function. And this function is going to take a list as its argument. Fine, you can pass a list to a function as an argument, no problem. And we'll put in the colon, and then it automatically indents for us, as always. We keep the indentation, we don't mess with that. And we're going to create a variable by assigning to it. We're going to say iLow equals the min, the lowest element in this list. We're going to get the lowest score. Okay, put it in iLow. And then we just say, well, remove it. Remove that value. Fine. And then we're going to do the same thing with the highest one. So I high equals max ilist. That will give us the lowest, or excuse me, the highest score. We already got the lowest. Get the highest score. And what do? We call the remove method to remove it. We're going to throw it out of the list. Again, we couldn't do that with tuples. Tuples are immutable. Lists are not immutable. We can change lists all we want. We can change the content of an existing list. So we've thrown out the low one. We throw out the high one. And we return the average, which is just the sum of the list. And we divide by the number of elements, which is len for the length, right? If I've entered that correctly, we'll take it. Oh, it likes it. So the function definition, grammatically correct, ready to go. And now we need a list to operate on. So I think we'll go back with those values. I'll put in the Finnish score and the Mexican, and there's the Russian score. And there's the Canadian score. Got really excited there. And the American score. And just to check this, what do we have? Yeah, we have a list. So if everything works, I should be able to run this function on this list. And by the way, something important to keep in mind. Python is basically dynamically typed for the most part. And one of the things that it does, it will let you put any kind of argument passed to any kind of function. It will not stop you unless you execute it and it doesn't make any sense. So be very careful about types in Python. Python is very loose with types. It'll let you do anything, but that makes the syntax much, much simpler. We run final score on my list, and okay, there we go. So if I just took the average of these scores, I'd get some number that is incorrect. But instead, we throw out the high, throw out the low, because of all the wonderful automatic features of lists. And we average it, and we come up with this number, and it's like, wow, okay, that's actually how they do the scoring at the Olympics. Python can do that, no problem. So let's summarize what we know about Python lists. Lists are one of the most powerful features in Python. This is really one of the coolest things in Python. A list does everything that a C or a C++ or a Java array does, but it can do so much more. And you don't need to do anything special. It's part of the language. It's part of the core language. And you get all this stuff for free. So it's amazing. Lists, just like most arrays, can have any kind of data. But one of the really cool things you can do is you can mix data if it makes sense for you to do that. And lists can even contain other lists. What happens if you get lists made up of lists? Well, you get a multidimensional list. You get a two-dimensional list, or you could have a three- or four-dimensional list. But this is what is possible. We're not going to go into two-dimensional lists in this course, but just so you know that you can do it. Another important thing to keep in mind about lists is that lists fully support indexing and slicing operations. They do almost exactly the same thing that strings do. So if you just understand the slicing syntax for strings, you will understand it for lists. But keep in mind that with strings, we're accessing characters and substrings. With lists, we're accessing elements and sublists. And finally, lists, unlike strings, are mutable. They are changeable, which means we can actually remove data from lists, as you saw in the demo, and we can actually change data in place. So lists, if anything, are much more flexible than strings. It's one of the most amazing things about Python.